Hello friends, we are continuing with video 5 of 20 practical data science videos, and today's topic is on ARIMA. We discussed AR and MA in the previous videos, so we combine AR plus I plus MA, that is what is ARIMA. As you can see on the screen on the right hand side, we have a data set of the blue plot, and ARIMA is able to forecast the remaining trend in red. So we will see how it can be achieved. Now the objective of this video is to perform a time series analysis using ARIMA. This stands for auto-regressive integrated moving average, and the principle is a statistical model that represents a time series as a combination of autoregressive, integrated and moving average components. And the principle behind ARIMA is to identify and capture patterns and trends in the time series, allowing forecasting future values. And always ARIMA is also a linear predictor. Output is predicted from previous history of data or errors also. Now if you consider AR versus ARMA, which were covered in the earlier videos, and also versus ARIMA, these are three different models that are used for time series forecasting, but their strengths or weaknesses are differing from one to another. And so AR is good for short-term simple forecasts without trends or seasonality, whereas ARMA is more accurate for moderate trends or seasonality. And then ARIMA, it is good for most versatile for complex data with trends, seasonality and non-stationary data. Now, AR would be sufficient for predicting short-term temperature changes within a day, that is an example, where only recent values matter more. Whereas ARMA might be suitable for forecasting monthly sales figures, incorporating both past performance and random fluctuations. Now, ARIMA could be used to predict daily website traffic, accounting for seasonal trends and weekend dips, etc. So ARIMA is the ultimate. Now the first part of ARIMA, that is the AR component, is the relation between observation and past lagged observations. A bit of AR we covered in last videos. So there was a lag order P, which was the number of lagged information included in the model. Now let's consider daily temperature forecasting from a data set of a city. The AR component tells how previous days of temperature can help to predict today's temperature. So mathematically you can write it, auto-regression YT is equal to C1, that's a constant, multiplied by the earlier YT minus 1, and plus C2 plus error. This is what we have discussed earlier also. So now AR in brackets 2, which means that considering the past 2 days. So that means today's temperature is not only dependent on yesterday's temperature, also day before yesterday's temperature. And phi1 and phi2 are the constants or weights. Now if phi1 is equal to 0.7, phi2 is equal to 0.3, then today's temperature is 70% of yesterday's temperature and 30% of day before yesterday's temperature. So how much influence each weight has on predicting the new value. Now the integrated component, this is a new term. This is the method of differencing of raw information by subtracting one observation from previous to make it stationary. So here the degree of differencing is called D. This means number of times the raw observations are differenced. Now For example, considering monthly sales data set in retail store, let's consider sales in January is 100 and in February is 120. Then we have I in bracket 1 component. It means that we are differencing the series ones. That means sales minus previous sales is equal to 120 minus 100. That's a difference. This indicates the sales increment from January to February. That way, integrated component transforms the original time series into a stationary one by differencing. We are going to see how this is going to work. Now, the third component, this is called moving average MA, denoted by Q. This represents the dependency between the current observation and the residual error. Here, the error is considered from a moving average model applied to lagged observations. Q specifies the size of the moving average window. Let's understand MA from this particular screen. This has been explained in the previous video also, but still, let's say you want to predict the number of cars required by a company every next day. So you have a table like this. The first day you do not know, you do not make any prediction, and number of cars required by the company was 4. So you put the same 4 here into the next place, the predicted number. The second day, since the number of actual cars required were 10, the error came out to be 4 minus 10, that is minus 6. So the next prediction is done using a formula, that is a mean plus C1 multiplied by error. So what is mean? Mean is nothing but 4, that is what is written. And C1 is a constant which we have given is minus 0.5. Then the error, previous error minus 6 is put here. That is what this formula says. Yt is equal to mu, that's a mean, plus C1 multiplied by error from previous. So then minus 6 is equal to 7. So difference is now minus 7. Same way, you take this minus 7 to next line and you apply this formula. That's a mean is again 4 and C1 is minus 0.5. Then the error was minus 7. So it came out to be 7.5. So actual number of cars required were 9. So it is, error is now reducing. So the whole point is that taking the error is helping you to keep up with the original trend. See, the trend, similar kind of trend is coming in both the places. You can see that actually. So from here, you understand that actually the moving average is the error has a big effect in forecasting. And ACF and PSCF, this is a very common terminologies. It stands for auto correlation function and partial auto correlation function. They are used to determine lag order and also the exact value, optimum value I. The autocorrelation describes the relationship between the observation and the on past values, that is lag. Now SCF function that considers both the direct and indirect effects of the values in previous time lags. For example, today's temperature is dependent on yesterday's temperature and therefore yesterday's temperature. Then the ACF considers the direct and indirect effects. Suppose the today's temperature is only dependent on day for yesterday's temperature, then you have to consider the PACF that considers only the direct effects. You can look at the complete program of ARIMA here. We are using these libraries in all the videos in this video and also the future videos also, pandas and matplotlib for plotting, and numpy is also used everywhere for the numerical operations. And in this case we are using an ARIMA model from statesmodels.api. First thing is you are reading the heater dataset which you have created, 300 points, and you are basically creating a dataset and you are plotting it. So after that you are passing AR order is equal to 3, integral order is equal to 2, MA order is equal to 3, let's say, and you are calling an ARIMA model here and fitting that ARIMA model. And when you do this, it predicts the future values from another 100 values here. And when you plot the output, the forecasted outputs, you see that the red curve, which is able to forecast intelligently, it is not just forecasting the initial value. See, it is forecasting the latest most things, and a trend is looking very good. Now the summary is, ARIMA models are widely applied in forecasting and time series analysis across various domains, providing a versatile framework for understanding and predicting patterns in sequential data. The effectiveness of ARIMA modeling lies in its ability to adapt to different data patterns through careful selection of the order of parameters, making it a valuable tool in statistical modeling and prediction. And now you can see all the programs, etc. in the description. Now I will go into demonstration of what has been discussed, and we call this program, and and you try to run this for you. So I just call the program which we discussed just now, and we are running it. Now the thing is, you remember that the loop here for I is equal to in range from 1 to 5. That means it will vary from 1, 2, 3, 4. I will vary. So the I is being passed. You can see that I is being passed as an integral component. All other things, AR order is kept 3 and MA order is 3, and this is being changed from 1 to. You can see that when integral component is equal to 1, MA order is 3, AR order is equal to 3, it's able to forecast somewhat. And in this particular case, when it is 2, it's able to forecast like this. Now MA is equal to 3, this is able to forecast like this. So for me, the first curve was looking even better, which was able to forecast almost in the similar direction or trend as the previous values. So see you in the next video. Thank you.